Welcome back to Project Euler, problem number 6, solve with JavaScript. This problem is fairly simple, however will allow us to explore recursion and functional programming. We'll use a combination of those two to solve this fellow with relative ease, hopefully. Enough yammering, let's get to it. Here's our problem discussion. So the sum of the squares of the first 10 natural numbers is 1 squared plus 2 squared plus up to 10 squared is 385. The square of the sum of the first 10 natural numbers is 1 plus 2 plus etc. onto 10 squared equals 55 squared, which equals 325. Hence, the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is 3025 minus 385 equals 2640. I'm going to be saying sum and squares a lot in this video. So here's our problem statement. Find the difference between the sum of the squares of the first n natural numbers and the square of the sum. In order to solve this problem, I'm going to use two things: functional programming and recursion. Before we get too deep into the discussion, I want to discuss recursion. If you're already familiar with the concept, feel free to skip over this part. Let's say we want to find out what is the total of all the squared values up to a given value, or in math terms, 1 squared plus 2 squared plus 3 squared on forward to n squared. To solve this, we can write a function that will do the following. Check if we have reached our limiter, square the value, add it to the total, decrement the limiter, return to step 1, and repeat. So let's write out our function. I'm going to call it get some squares. We're going to pass in a ceiling, and again we're going to pass in a total, and we're going to set it to 0 initially. The first thing we're going to do is we're going to check to see if we have reached our ceiling, and if we have, we're just going to return total. Next, we're going to square the value and add it to the total. Next, we're going to decrement the limiter and return to step 1. So let's return our function. We're going to reduce the ceiling by 1 and then return the total. Now, if we call our function get some squares, you'll see that we get the answer that we were looking for. The steps for this problem are fairly simple in comparison to number 5. We're going to calculate the sum of all squares up to n, calculate the square of the sum values up to n, and then calculate the difference between the two. I think I've talked enough. Let's code. As I mentioned earlier, we will be composing our solution via functional programming. That means we will be creating 3 separate functions. The first one we already did in the discussion about recursion. However, let's go over it again. The first function we want to make is the get some squares function. And this is going to take in a ceiling and an initial value that's going to be our total that's going to get returned at the end. So immediately, because we're going to be using recursion, we want to make sure we give it an out. So we're going to say ceiling equals 0 and then return total when that happens. And then we're going to say let squared equals total plus equals ceiling to the power of 2. And then we're going to return recursively get some squares. Our ceiling is going to be the ceiling minus 1, and then our total is the total. The second function we're going to do is going to be get square sum. Again, ceiling, total, starting value of 0. If our ceiling is equal to 0, return total squared. Well, not to the power of 22, squared. And then we're going to make our total plus equals plus equals our ceiling, and we're going to return recursively square sum ceiling minus 1 with our total. This makes coding our main function incredibly easy because all we got to do now is get the sum of squares equals get sum squares with our n, which is the value that gets passed in. We let our square of sum equals get square sum, again with an n. And then we return the square of sum minus sum of squares. And if we run our tests, ta-da! Good job, team. Let's briefly review the whole thing so we make sure that we've covered all our bases. So we've got our three functions. We've got our getSumSquares function, we have our getSquareSum function, and then our SumSquareDifference function. So the getSumSquares is going to be adding all of them together. So you're going to get the 1 square, 2 square, blah, 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 all the way up. Our getSquareSum function is adding all these numbers together and then finally squaring it to get that one. And then within our main function, we've got to getSumSquares, getSquareSum, minus those two together, and then finally we get our answer. Well, I hope you had as much fun as I did solving this thing. I love clean code. So using those two methods, recursion and functional programming, we have a nicely composed solution that is highly legible. Like all things, this can be improved. If you got recommendations or improvements, throw them down in the comment and let me know. As always, happy coding.